determine whether the linear binomial is a factor, we'd have to find the 0 of x minus 1, which is -1. So we put in f of -1 into x. So I'd have to put it in parentheses. -1 squared would be 1 minus -2 times -1 would be +2 minus 2. This equals 1, so it is not a factor. If it equaled 0, it would be a factor. To simplify these, for number 2, to get rid of a negative, I put in an I. So I would have 5i square root of 24. Then I can break up square root of 24 into be the square root of 4 square root of 6. So it'd be 5i square root of 4 would be 2. Square root of 6 doesn't split up. So I'd end up with 10i square root of 6. To solve for number 3, we'd have to get x by itself. So I bring over the 25. And how do I undo square? I square root each side. So I'd have x squared square root equals square root of -25. And then from here, I'd have x equals, to get rid of the negative, I bring out the I and square root of 25. So this would actually be 5i, because square root of 25 is 5i. And then to plug it back in here, we could have a plus or a minus. We could have a plus or a minus for that one. To change to 31 degrees, change that to radians, so 31 degrees. I want to get rid of degrees, so I put degrees on bottom. I want to change it to radians. I know pi radians is 180 degrees. This way my degrees cancel. I'd have 31 pi over 80 or 180 radians, because now I'm left with radians. To change this, negative pi over 7 radians, and change that to degrees. To get rid of radians, I put radians on bottom, and I can change that to degrees. 180 degrees is pi radians. I know that my radians cancel, my pi's cancel. I'm left with negative 180 degrees over 7.